Have you ever wondered how Mars, the red planet, came to be? Like our very own Earth, Mars was born around 4.6 billion years ago. In the early chapters of its existence, Mars was a hotbed of geological activity. Picture this: massive shield volcanoes erupting, painting the Martian landscape. The most famous of them all, Olympus Mons, stands tall even today, a silent testament to Mars's fiery past. Now, Mars's atmosphere is a lot thinner than ours on Earth. This thinness, while limiting in many ways, permitted volcanic gases and water vapor to escape into the vast expanse of space. This escape was a crucial part of Mars's early life, shaping its geology and climate in ways that still mark the planet today. Thus, Mars began its journey with a bang, quite literally, through extensive volcanic activity. From its birth to the present day, Mars remains a fascinating world, a testament to the dynamic nature of planetary evolution. But did you know there was a time when rivers flowed on Mars? Yes, indeed. About 3.5 to 4 billion years ago, the red planet was not so red. Back then, Mars had a much denser atmosphere that allowed liquid water to flow freely on its surface. This period in Martian history was characterized by the formation of river valleys, lake beds, and clear signs of water erosion, painting a picture of a planet that was once lush and possibly teeming with life. However, as the eons passed, the Martian atmosphere began to thin. The planet's smaller size and weaker magnetic field couldn't hold on to its gaseous envelope as efficiently as larger planets, like Earth. As the atmosphere thinned, liquid water became less and less stable on the surface. Over time, this led to the gradual disappearance of water from the Martian surface. The once blue Mars slowly started to dry up, marking an end to its watery era. The disappearing water was not the only change Mars experienced. Over time, the red planet lost a significant chunk of its once thicker atmosphere. This atmospheric loss was largely due to its lower gravity, unable to hold on to the gaseous envelope as tightly as larger planets like Earth. But there's another culprit at play, and that's the solar wind. This stream of charged particles emanating from the sun can gradually chip away at a planet's atmosphere, especially one without a protective magnetic field such as Mars. This thinning atmosphere had profound effects on the Martian climate. As the atmosphere grew thinner, it became less capable of trapping heat from the sun. This, coupled with the planet's greater distance from the sun, led to a drop in temperatures. The once possibly warm and wet Mars became a cold and dry world. As Mars's atmosphere thinned, the planet was left colder and even more desolate. Yet, Mars is anything but a quiet, static world. It's renowned for its global dust storms, a spectacle that can envelop the entire planet. Imagine a whirlwind of dust particles shrouding the Martian surface, an event so grand it can be observed from space. These storms are not just a sight to behold, they're also a powerful force of nature, contributing to the weathering and erosion of Mars's surface features. Now you might be wondering, what's the big deal about some dust? Well, the dust on Mars plays a crucial role in determining the planet's albedo, which is essentially its reflectivity. A higher albedo means more sunlight is reflected back into space, and less is absorbed by the planet. This affects Mars's surface temperature and overall climate. So, in a way, dust storms on Mars are like nature's thermostat, influencing how warm or cold the planet is. Even today, Mars continues to change, shaped by its powerful dust storms. From a warm, watery world to a cold, dusty desert, Mars has transformed dramatically over billions of years. Born around 4.6 billion years ago, Mars was once a hotbed of volcanic activity, leaving behind towering volcanoes like Olympus Mons. A denser atmosphere then allowed liquid water to flow, carving out river valleys and lake beds. However, the planet's smaller size and weaker magnetic field contributed to a thinning atmosphere, making water less stable and leading to its disappearance from the surface. This atmospheric thinning also made Mars colder and less able to retain heat. Over time, Mars experienced weathering and erosion due to its global dust storms that could envelop the entire planet. Despite these harsh conditions, the presence of clay minerals and potential subsurface aquifers hint at a time when Mars might have been hospitable to life. As we continue to explore Mars, who knows what other secrets this red planet holds about its past, present, and future.